Well, hello everybody. Welcome. And as you can see, we've lost a few of the locals today, but we've been joined by some old regulars. We've got Tom. Nice to see you, Tom. How are you?
I'm good, Dennis. How's everyone?
Oh, we're struggling on as we must. And the lovely Rachel is back in the house for
Hey.
tonight. How are you?
Yay!
I'm just laughing at Tom's name.
Yeah, I know. He's
Tom
ambitious, isn't he?
Cruise. Very
Well,
ambitious.
you've got to
It's
have
probably the
ambition.
same height.
Yeah.
I
That's
think I'm
Yeah, but
about
low.
half an inch taller, actually, to be fair.
that's a mission impossible, a mission too far. But yeah. And Roger, how are you?
I'm fine.
Good, 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 good. We've unfortunately Michael is out socialising, so we're hoping he's having a good time. Having a few cherry bees and a couple of baby shams.
Lovely.
Lou is flying at this moment in time to visit family, so
He
safe
is. He is
landings.
on. He's just said hello.
Oh, is he? Okay then. So thank you, Lou, and nice to see you. Hope you're having a great flight and enjoy your family time. And we've lost Andy. Unfortunately, Andy at the moment is bedridden. He's injured his back, unfortunately. Now, he's telling everyone that he injured his back fighting off wild boar in the local forest while saving a damsel in distress. But to be quite honest, I think that's a load of bull, and I think he just slipped in the bath. But anyway, Andy, look after yourself, and we'll hope you get better soon, and we'll speak soon. So all well and good. Anyway, you're stuck with me tonight, so it's going to be a rambling show. As you know, always. I haven't done this for a while. But what we will do is we will start with a bit of what should we do? I'll tell you what we'll do. We'll do with a bit of uh, housework. Housework.
Yeah.
So what we will do, I'm going to do the vacuum.
Oh dear.
No! No!
Yeah, we're off
Rod-
already.
Roger's
So anyway,
Come back, Andy.
if you'd like to buy us a coffee, please do click on the QR code below, and it's also should appear in the chat for you to be able to click on. So yeah, so I think it's just so rude how this tends to cover the people at the bottom, but serves them right for coming in late. But anyways, anyway, so if you'd like to buy us a coffee, please do. And as I always say, all the money that we receive goes straight back into keeping us on air, helping us to produce these shows. It all costs money, unfortunately, but we enjoy doing this, and please, we're grateful for anything that you can supply us. So if you'd like to buy us a coffee, and it's being bracketed, I see now, so off you. And also, if you'd like, visit the Space Oddities shop where we've got T-shirts and hoodies. I think that I'm not going to mention the prices because I'm unsure. I think the hoodies are £40, postage free. And if you are ordering from abroad, just add £10, and it's the same with the t-shirts. I think they're about £20. I'm absolutely useless at this. So oh yes, it's just written above it. So sorry. So anyway, if you'd like to click on the QR code or click on the link, and you can visit the shop for us and all that. So I thought I'd get that out of the way because I knew I'd mess that up. So anyway, right, tonight we're looking at citizen science. Now, we've always talked about citizen science and how it's going to become more and more important over the next few years with all the I mean, we've got all the Gaia data that's still coming in. We've got Euclid, we've got Webb, we've got Hubble still, and basically the data that is coming in, and we've got now we've got the Vera C Rubin, which is going to produce so much data every night that nobody's going to really be able to look at it. So what we need is some way of actually looking through the data and categorizing it. And this is where citizen science will come in. So what I would like to do is to start. Please bear with me because I had to knock these up quite quickly. But first of all, what I will talk about, let me just get rid of this QR code. Get rid of that, thank you. So we can see Rachel and Tom Cruise. So anyway, I'd like to, what I would do is I'd like to share this. Can everybody see that?
Mhm.
Yep. We can
Yep.
add, so get rid of that so we can see the bottom of it. Now, basically, what is citizen science? And basically, it says here, empowering public participation in science research. Citizen science represents a powerful collaboration between professional scientists and members of the public. By involving everyday people in scientific research, we not only advancing knowledge, but also democratize science itself. So basically, what they're asking people to do is well, basically give them a hand. That's what we're basically doing. So, what exactly is citizen science? Citizen science refers to people participating in non-professional participation of non-professional scientists in scientific research. It involves members of the public, basically collecting data, analyzing results, and even helping design studies. Collaborative approach bridges the gap between scientific institutions and communities, making science more accessible and inclusive whilst expanding the scope of whatever researchers can accomplish. The evolution of citizen science. Well, it's basically well, the name that was coined in the 1990s. Citizen science, but it has actually started back in the 18th and 19th centuries, where amateur naturalists like Charles Darwin made significant contributions to science and to, the knowledge of everything around. Today, digital tools collectively have transformed citizen science, enabling millions of to participate in global research projects through smartphones, websites, creating vast collaborative networks of knowledge and production. So basically, the more people who get involved, the more we'll be able to actually do. The key benefits of science enables collections of vast data sets across the geographical areas that would be impossible for professional scientists alone, accelerating research in fields like ecology, astronomy, and public health. Education, which Rachel knows all about, provides hands on science learning experiences, improving scientific literacy, and creating meaningful connections between participants and their natural environments. It also empowers communities to address local environmental and health concerns, fostering civic engagement and providing evidence for policy advocacy. So basically, you can actually change people, change how things are being done around you to make your life better and the life of everybody else around you by participating in these events. Successful science projects, Galaxy Zoo. Well, we'll talk about that a little bit later. But over 150,000 volunteers have classified millions of galaxies, making discoveries that that automated systems missed. Now, this is where most people started in the astronomical realm, because Zooniverse was actually started by Chris Lintoff, Dr. Chris Lintoff, he of Sky at Night fame. And it was basically, as we said, a method of actually going through vast amounts of data sets by using people who are not actually trained in it. There's eBird, which is recorded over 10 million bird observations annually, creating the largest biodiversity data set. And gamers even helped with the structure of AIDS-related enzyme that had puzzled scientists for years. So even sort of like gamers in the gaming community have helped develop vaccines and map out different things that have confused scientists for a long, long time. Challenges in citizen science. Um, Data quality concerns. I mean, ensuring accuracy and reliability. Data collected by volunteers with varying levels of expertise requires careful project design and validation processes. Uh, and of course, then we've got participant retention. I mean, keeping people involved in this. So it's got to be interesting and in fact, really, to be quite honest, I think of these projects should come with a government health warning. You will become addicted. I spent the other day because we were talking about it. I'm supposed to be doing research. I spent 5 hours basically looking for
Wow.
gravitational waves and analyzing them. But anyway, that's by the by. Just be careful, you will be addicted. You can lose time quite easily. And you've got there's also equality and inclusion. Of course, certain communities don't have access to the internet, or they, don't have computers and all that. So basically, you need to be able to find some way of including everybody in underrepresented communities. So you've got to watch that, because these people are not participating, that it's potentially skewing data collection. So future of citizen science. Well, of course, we all know that we know, especially in the astronomical society realm, that we've got all these big new toys that are coming online. The Vera C. Rubin being the latest, which are going to have produced or are producing massive data sets. So basically, emerging technologies are expanding the frontiers of citizen science. Artificial intelligence to enhance data analysis and validation, low cost sensors enabling more sophisticated environmental monitoring, augmented reality interfaces making participation more intuitive, and blockchain for transparent data ownership and attribution. So citizen science is going to be getting bigger and better all the time. So using just the technology. So how to get involved in citizen science? You basically the best thing to do is just whatever search engine you're using, just Google citizen science and see what you find. Of course, you can narrow down the search if you're looking for space ones. But like here it says, find a project, explore platforms like Zooniverse, SciStarter, and citysci.org to discover projects aligned with your interests, from astronomy to zoology. Understand the requirements. Some projects need only a smartphone, while others require some specific equipment or require commitment. Choose one that fits your resources and availability. Submit your observations, engage with the community, and watch how your contributions help advance scientific knowledge and address worldwide challenges. So basically, that's what citizen science is. And as I said, you can join any of these links. And like I say, if you just Google citizen science projects, you will be inundated with loads of them. Of course, me personally, I'm more down the astronomical line. So my later on, hopefully, I'm going to next thing I'm going to talk about um, is Zooniverse itself, because of course this is the one that most people go to. But remember, Zooniverse is not just about the universe. It covers so many different objects. And later on, if it works, fingers crossed, I will actually be running through my account live just to show you how easy it is. So, so that's basically what citizen science is. So, what we will do next, I will just go run through Zooniverse so we know what sort of things we're talking about. So, let me just get rid of this, get this up. Okay. So Zooniverse, revolutionizing science through citizen participation. Join us on a journey through the world's largest platform for people-powered research. And I'll tell you what, as I said, be very, very careful. You will lose days on this if you're not careful, because it is so addictive. So let's move forward. What is Zooniverse? Zooniverse is the world's leading citizen science platform, enabling volunteers worldwide to contribute to real scientific discoveries without specialized training. It was founded in 2009, as I said. It was by Chris Lintoff, who came up with the idea. And it has grown from a single galaxy classification, which was the Galaxy Zoo, which everyone really got hooked on, to hosting over 200 active research interactives across disciplines. How citizen science works. Scientists upload the data. Well, that's common sense. You've got to have something to be able to look at. Researchers share data sets too large for automated analysis or requiring human pattern recognition. Because one of the things, AI is very good at spotting lots of things, and it'll also spot some things that we can't do. But the thing is, humans are great at actually recognizing pattern recognition, which AI will sometimes miss. But this, of course, as AI gets greater and advances, then hopefully, it will be able to pick out more and more. Volunteers contribute. People worldwide classify, tag, or analyze small portions of data, which we'll look at later through intuitive interfaces. They've got to be interesting to keep your attention. Results drive discoveries, lead to peer-reviewed publications, and genuine scientific breakthroughs. Now, with citizen science, and I'll mention it probably again later, is that if you join citizen science, you can do this for free. You don't actually have to sign up. But if you do sign up with Zooniverse, whatever you actually choose to do, if papers are written, your name will be attributed to that paper. You will actually get your name on the paper because you've been part of the actual discoveries that have been made. So that's something, a bit of a feather in your cap. Galaxy Zoo, as I said, the original Zooniverse project has classified over 3 million galaxies and led to the discovery of Hannes Vorwerp, a mysterious astronomical object. So that was discovered through Galaxy Zoo by people just classifying different galaxies. Ancient lives, you've got volunteers transcribe over 1.5 million fragments of papyri from ancient, okay, Oxyfiscus or something like that. Sorry if I butchered that, which I obviously have, revealing previously unknown Greek texts. And Penguin Watch, penguins, enabled monitoring of remote penguin colonies across Antarctica, providing crucial data on population changes to climate change. Well, of course, they don't expect you to pop down to the Antarctic and go and individually count every penguin. It's all done with satellites. So you can sit in the warmth of your living room on your computer and you can count penguins to your heart's delight. And it's the same with Galaxy Zoo. It's the same with everything, actually. You can all be done from your own PC. Or even some of them just the phone, especially with Galaxy Zoo, because as long as you've got a decent screen, you'll be able to pick out the object. So there are 2.3 million people participating. I can't read this, sorry. I think it's 200 papers have been, 170 papers have been written, and there's over 200 projects that you can actually join. I remember now. And there's, like I said, 170 papers have been written. So that gives you some statistics. Current research domains: space exploration, identifying exoplanets, galaxies, mapping the moon and Mars, biology and medicine, tracking wildlife, analyzing cell structures, and contributing to cancer research. I mean, there was one that had people looking for cancerous cells, and they discovered lots more than the AI did. So people had advanced warning of things that possibly they needed to possibly go and get themselves checked. Humanities and history, translating historical documents, deciphering ancient texts, and preserving cultural heritage. Well, this was transcribing historical texts. It can be letters from World War One. It can be diaries written by famous people or just general people, normal people in the past, giving us an insight into the history of the time and what was actually going on, what they were actually thinking. Climate science, again, this is mostly an astronomy, a satellite-based event, but also you got monitoring environmental changes, tracking severe weather, and analyzing climate patterns. One of them is just analyzing and identifying clouds. And again, you use you can use your mobile phone for that. So. Benefits of participations for volunteers, you learn about cutting edge science, contribute meaningfully to research. As I said, if you join up, you could even get your name on a scientific paper. Join global communities of like minded people. And most of these places have chat rooms. So you can actually go on and actually talk to people who are doing exactly the same as you are. No specialized knowledge is required. Now, this one tends to put people off, but really, especially with the Zooniverse, you get a tuition before you actually start. It's just a quick flick through. It tells you what you're identifying, what to look for, and then it's basically baby steps. And I'll show you one that I'm doing at the moment, which I have to achieve different levels. Once I've achieved a certain level of identifying a certain type of whatever I'm looking for, then they will move me up, and I then get more things that I need to identify. For the scientists, they process enormous data sets efficiently, which is what they're looking for. Harness human pattern recognition abilities. So they're also analyzing whether or not we can actually see these things, engage the public with research, and accelerate discovery timelines. So yeah, they're also monitoring us. As I said, with this no specialized knowledge, don't matter if you think you've made a mistake, because at the end of the day, if you're given an image that you've got to find something and you think you've marked it wrong, you're not the only one who's looked at that. You'll probably find 200 or 300 people have looked at the same image, and they have actually done possibly the same, or they will see something different. So everything is checked several times before it's actually, uh, used in any papers and that. And also, uh, basically join the scientific revolution. Don't it's so easy, especially Zooniverse. Visit zooniverse.org. Within sort of like 10 minutes you will actually be doing some actual solid research, and it's meaningful research. It's not just a game or anything like that. Basically make sure you create an account in Zooniverse, because as I said, you will then be attributed to any future papers, and just start contributing. As soon as you click on there, within 10 minutes, you can be looking at galaxies that no one's ever seen before, and you could be the discoverer of that. Unfortunately, you don't get to name it, which is sad, because I don't think they'll have 2,000 galaxies called DAS 1, DAS 2, DAS 3. That'll be a bit boring. So yeah, so that's basically Zooniverse for you. So if I just get rid of this one for you. So that's what Zooniverse is all about. And as I said, in a little while, everything willing, um, just delete this. I know you're getting sick and tired of my voice, but I've just got one more. I want to get these out of the way. They were pretty rushed to set them up. And by the way, these are all done in Gamma, which is a massive new discovery of ours. It's an AI, and it will produce PowerPoints for you within seconds. So this is how I was able to do this, because I had very little time to be able to what's it. Now this one, I mean, again, we're talking about astronomy, because this is what we like. And as I said, I'm sorry I'm droning on a bit, but I'll just get rid of this one. It's another 8 slides. So this one is about NASA. So, but as I said, you can find these anywhere. I did do one at one time where I just had to sit and go through all these photographs, and it was photographs from a deserted island in the middle of the Atlantic somewhere, looking at a bay. And what you had to do is just go through. It was constantly taking images, and we had to go through all these images. And what we were looking for is killer whales' dorsal fins, because they wanted to know when these whales arrive, and we had to try and do a count. So that one, although it was very um, long-winded, because you were looking constantly over days, over days, over days, and you wouldn't see anything. But when you did see a dorsal fin, you were really made up and you were able to count. And if you saw two in the image, absolutely fantastic. But again, you were contributing to the ecology and the life cycles of the killer whales. This is what people wanted to know. So basically, I mean, another place, a really good place for astrological and other and weather things and earth science is NASA science. So you can just click on, go onto NASA, go onto NASA apps and all that, and then look at citizen science. And you basically, it will take, you can embark on a journey into extraordinary scientific discoveries. These programs bridge the gap between professional scientists and enthusiastic amateurs, demonstrating space exploration and democratizing space exploration and research. So, what is citizen science? Well, we went through that a little bit earlier on. Citizen science empowers everyday people to participate in scientific research, expanding NASA's capabilities beyond its professional workforce. It transforms space exploration into collaborative global endeavor. Through these programs, volunteers contribute to real scientific discoveries, from identifying distant galaxies or tracking changes in the Earth's environment, all whilst learning and engaging with a cutting edge research. NASA Global Observer. So you've got cloud. This is when I was on about cloud observations. Participants photograph and categorize clouds, helping scientists track cloud patterns and validate satellite data. These improve our understanding of Earth's climate systems and weather prediction models. Tree height measurement, measuring the height of trees using the app's what's that say? Clinometer. um, Contributing to global forest biomass estimates. These measurements help science understand carbon storage in forests and ecosystem health. And oh, is a nice one. Mosquito habitat mapping. Well, of course, this is really important because in some countries, mosquitoes are the biggest killers of human beings, with malaria, sleeping sickness, and things like that. But also they're just an irritant in Europe, basically. But the dangerous breeds, because of the climate warming up, these dangerous breeds are moving further afield. So we need to know where we're going to find these horrible little midges that and where they're breeding, and how we're going to actually deal with them. And of course, I mean, there was one with the Zika virus. I can't remember where it was. It was somewhere in South Africa, I do believe. Where one of the things they did was they realized where these colonies were. So what they did is they bred genetically changed male mosquitoes that were incapable of breeding, and released them into the habitat. And of course, next thing you know, the population's diving. So this is what we're looking for. So that again, that's all help with the help of citizen science. We got here partners with Zooniverse on several projects that harness the power of the human pattern recognition to classify astronomical objects and phenomena that computers might miss. So you got Galaxy Zoo, which we've already talked about, and how successful that was. Solar Storm Watch. Now you know me, I love the sun. So you can actually watch and look in, because I'm doing one at the moment, which is I'm counting sunspots in drawings that have been made, 100, 200 years ago. So I'm actually capturing the sunspots. And what they're doing is they're getting all this information together to see how the sun has changed over the last couple of 100 years, since people have basically been mapping sunspots and the regions. But here you can track solar eruptions and help scientists predict space weather, which will affect Earth satellites and power grids. And planet hunters, if you want, you can go and search for planets. Again, there's another one I'm doing at this precise moment. Again, looking for planets using data sets from telescopes and analyzing the dip in the light that comes through. So you've got binary systems, you've got all this other. You'll see in a little bit later on. But this is what you can do actually on NASA. Aurorasaurus. This is quite a good one. This is where people have taken photographs all over the world, or it just reported sightings of aurora in real time, enhancing our understanding of these spectacular phenomena. Reports improve the space weather models and help scientists track geomagnetic storms, how they affect the Earth. And there's also one here, landslide reporter, and it's people reporting landslides in their area, which again then looks at data helps researchers develop better prediction models and improve early warning systems. So all this stuff is actually going back into the real world and helping to, like I say, make predictions, save satellites, save basically the electrical power systems, because we know that they can be affected, and we've learned that going back into the 1800s with the first big storm that we had, and I'm waffling. I've totally forgotten the name of it. So anyway, let's move on. Let's just gloss over that. Asteroid hunters. You can be looking for asteroids. You can be looking for new planets in the solar system. Remember, we're all looking for Planet 9 at the moment. It's hiding out there somewhere, they do believe. So you could be one of the people to actually find it by looking at the data that's things. Asteroid data hunter, you're mapping the movement of the asteroids, and whether or not they're actually going to become a hazard to or near Earth objects, which could become hazardous. And target asteroids to observe specific asteroids to support NASA's OSIRIS-REx mission. The observations proved valuable data, asteroid properties and behavior, and the complements spacecraft measurements. Again, educational impact and achievements. Well, of course, if you're there's no way you can't learn things from when you're actually doing things. You're actually dealing. You've got your hands on the data. You learn about how this data was collected, because all this is provided when you actually click onto these things. So over 300 peer-reviewed scientific papers using citizen science data. This is scientific contributions. Discovery of new astronomical objects included, as I said, Halley's Vorwerp, or something. Creation of the largest landslide database with 12,000 entries. Validation of satellite observations through ground-based measurements. And the educational benefits? Well, engagement of over 1.5 million participants worldwide. Integration into UK school curricula through educational sources. Don't know why that's moved there. Development of STEM skills and scientific literacy. Increased public understanding, NASA's mission and scientific challenges. So I do apologize. This is the last slide, so we're all glad to hear. So you can join NASA's citizen science community, download NASA apps, or visit scienceinactionnasa.com and connect with other citizens all doing the same thing as you are. And basically, the sooner you do it, the more you'll be intrigued. So, and you'll be learning stuff, and you'll be helping science in a great way. So that's that for now. So I hope you didn't get too bored. I mean, some of it was a little bit repetitive, but there we go. So thanks for that. Anyway, anyone got anything to add to that?
I mean, I just think if anything's getting people involved in real Earth science research, and you can do it with a phone and validate satellite data just by photographing clouds or you're mapping land, whatever you've done. It's you get an instant feedback, and it's global. So if you're helping communities on a global scale, it has to be for the good, right?
Exactly.
Absolutely
I mean,
agree. Absolutely agree. I think it's fantastic, actually, just that I heard a quote the other day there from, or I maybe read it from somewhere, and NASA rely quite heavily on this kind of stuff, not just the data that they present, but the data that we can pull using our telescopes. They kind of rely on that kind of stuff because, and maybe not so much in the UK, certainly not in Scotland, but in the most part, we're out quite a lot, and we're seeing stuff that maybe they're not spotting. Was Schumacher 11.9, was that caught by an amateur astronomer? So
that's
that
right.
kind of stuff.
Yeah, I mean, we were talking about comet searching. Of course, the main part of the sky now is basically covered by these big projects and the big telescopes. But the one place they can't really look and detect comets is near to the horizon at dawn or at dusk. So that's where the amateurs are looking, and they are still pulling out comets to this day. And of course, you find a comet, you get to name it.
Yeah, exactly.
I'm still waiting for Comet Daz yet, but there you go. It's good.
or a
Yeah,
supernova. I mean, there's lots of amateurs that are
exactly.
finding
Yeah,
supernovas. So,
exactly. I mean, because of course we've had two supernovas, haven't we, in the last couple of weeks? So and some of these, as you said, have been discovered by amateur astronomers. So there's always the chance that you're going to pick something up. And as you were saying about NASA using citizen science, they're using. I think there's one coming up in about the 10th of July or something like that. I know SLU are involved. They're the remote telescope company. They're very good. They're well worth a look if you want to use remote telescopes. But they are collaborating with citizen science groups all over the world, and they're going to be looking at the moon on a certain night, and they're all going to be looking for impacts. So they're going to train their telescopes on the moon and look for meteorite impacts actually on the moon. Because I can remember when I was with SLU, we were doing I don't know, I think it was a full moon or something a special full moon or something, and then we were doing a show, and lo and behold, we had a hit then, which wasn't picked up by us at the time, but it was picked after the show. We saw it had been released, and when we went back, yes, lo and behold, it was there. So yeah, I mean, it's amazing what people are doing. Another one that's I think it's NASA's doing, is called Moon Diff. And what you do is you get two images taken by lunar orbiters, and they're taken at different times, and it can be either years or it could be just decades, or a few months or something like that. And then you just compare the two images, and you're looking for new craters, little pinprick craters, anything that's changed to indicate that there's possibly a new crater been formed by something. Again, we've got the sun one as well, and there's plenty of apps that you can join on there and join in analyzing CMEs, flares, and things like that, and helping with things like that. There is just so much, and then of course, then you've got the earth science, and again, it's all database. You could end up analyzing crops in Africa or something like that, or vegetation in different parts of the world using satellite imaging. So it's very, you're spoilt for choice. You really are. And you can spend, like I said, hours and hours and hours of doing these things. Anyway, I think that's enough for citizen science for the moment. What I'd like to do now is hand it over to Roger so I can have a drink and get my voice back. So off you go then, Roger.
Can't hear you, Rog. No.
Oh, we've lost you, Rog.
We've lost him.
We've lost you.
I said I've just been admiring how perfectly his hair matches the moon shades behind him.
Exactly. Yeah. Yes. It's a
It's like a
lunar.
little
That's
tulip
the look.
colour swatch.
That's the look he's going for.
He'll be
It's
forever
called
known as
lunar.
Lunar Roger.
Yeah. When you go, if you want it done, it's called lunar lights. So.
Still can't hear you, Rog.
Yeah, but he can't answer us back now, so we can take the mic.
I can hear you.
Are you there, Rog?
It's very faint.
Just hear him. Yeah, just hear him.
Right, well, you sort yourself out then. What I will do. I wanted a break. No, we can't hear you at all, Rog. I don't know if you want to, because remember, if you pop back in and out, you'll probably lose your. No, nothing's coming through, Rog. No. Anyway, right, let's move on. Let's find something else that we can talk about. Well, I could go into Zooniverse, but I didn't want to do that quite yet. I wanted to split it up. Are you there, Rog? No, you're not there. No problem. So what I'm going to do is I'm going to move on. What I will do is I'll stop sharing this because I don't want to do that yet, and I will go. Where's that gone? Where's my thing gone? I will just pop this up.
Roger's gone.
And then there were 3.
Yeah, he's going to go out and come back in again. So let me just do this. I'm going to now. This was something that I'm trying. This again is being done with Gamma. It's a quick. Oh, what is in it there? Windows Media Player. That's what I want. So what this is a quick. This is a quick forecast.
I can't see your share.
No, I'm just going to pop it out because I think it will start as soon as I click on it. So here we go. There'll be no talking. It's just a few slides, just telling you what's happened in the thing. So here we go. There we go.
Yay.
It's not starting now. Right, here we go. But I was able to see that. And basically that was just a quick weather report of what's happened. I actually produced it yesterday, and it was using gamma again, and I just slipped in a few images ourselves. Now, the most absorbent amongst you will notice that there's a possibility of over tonight that there could be an aurora alert, and also which will run into the 3rd and the 4th. The reason being is that there's been some filament action. There's been filaments lifting off. There's some really big filaments that have been done. You probably saw in that image the 2 filaments that launched off the western limb. We have been following them all the way across the sun over this half cycle, and they're absolutely huge. And we were just waiting for them to pop off. And as always happens, they pop off when they're on the western limb, which means they're going away from us. But there are also some quite large coronal holes, especially CH61, which is coming into Earth, is in line with the Earth at the moment. And that's given us, and this will answer Chris Rears, what is slightly elevated solar wind speed? And this is where we've constantly got a wind, a solar wind coming from the sun, bathing us. But when we get coronal holes or we get CMEs, flares, and all that, these can actually enhance the speed of the winds. Now, the higher the winds, and they reckon that this can be, they reckon they've underestimated the actual speed of the winds of what's coming over the next couple of days, and it could be treble. I think they're looking at about the most 200 miles per second, but they're looking at they'll possibly be as large as 600 miles, 600 to 700 miles per second, which means we will get aurora. Remember, all the ducks have got to line up. We've got to make sure everything happens, especially the BZ rate. It's got to be south, and then basically we will possibly get auroras. So just keep an eye on your auroras. I've just checked and I've got dirty clouds. So just keep an eye out, listen for your alerts. And as I've recommended before, and I'll promise you, we'll be bringing you an update soon of how to get onto the half-hour warning system, because that'll give you far more. Remember, when you look at the KP index, that's 3 hours old, so you've probably missed the main event. So that's what's happened in the last 3 hours. So you rush outside, set up your thing, and then you'll be your photo, your camera, and then you'll find that there's nothing there, and you think, oh, well, that was a bit of a waste of time, you know. And then next day you see lots of people have caught it. So if you are using the KB, as soon as you get a yellow or an orange alert, get your equipment out, put it on time lapse, and just let it click away and see what happens. But if you use the half hour, the HP 30, which is every 30 minutes, that will give you a more accurate reading of what's actually going on. I would put the website up. What I'll probably do is I'll do talk about the difference. I mean, it's exactly the same as KP, but it's every 30 minutes, and the HP is to do with actually the name of the institution that actually produces this. But you can get a 10-day look, or you can get sort of like a day look, or the last few hours. But remember, that is every half hour, not every 3 hours. So you get a better chance of actually being able to capture the images that you actually would love to own. So and it can happen at any time. So just keep an eye on those alerts. The sun is, although it's fairly quiet, it's active in a lower level at the moment, but at any time that could change. Because usually we get just as much, if not more, activity on the downslope of the 11-year cycle, which we're well into. In fact, today we should get the last month's reading, so we'll be looking at that possibly next week. So it looks like we've actually lost Roger, which is really unfortunate. So what we will do now.
I was just going to say, Daz, that the app that I use is Aurora Watch. That's quite a nice little app.
Yeah, yeah. There's Aurora Roch, there's a Aurora UK.
Yeah.
But make sure you try and get an English-based one. This is the thing. And another one to do is the I'm here. He says he's here, so I'm just gonna get
Here's
Roger in.
Johnny.
The best book I've got is the WhatsApp chat,
Hello.
because I just sit in a WhatsApp chat with all my Astro friends, and they will start pinging as soon as they see it, and then I go out and see it.
Yeah, exactly. Well, that's the way to do it,
As
because
soon
you
as
know it's
the
happening.
images start coming in, then you're like, "Yep,
Yeah,
it's
you
happening."
know it, because then you know it is actually happening. But as I said, we always get, sometimes we get so excited we'll have a massive X flare, and then we'll get nothing, because again the ducks didn't line up. There's always one that goes off to the right or left, and that means we won't get any aurora, and it's a sad state of affairs. But the aurora is virtually a constant at the moment, but mostly up in the Arctic regions, and the Antarctic regions, because they're not giving us the oomph. But this one possibly, just possibly, could. Right, Rog.
Here's a quick question, actually, Rog.
Oh,
Before,
sorry.
do you think the one in October was stronger than the one in May last year?
Yes, definitely.
Yeah.
Because it was red, not orange.
Yeah. So I stood in the back garden for about an hour and 40 minutes, and I swear I could feel colours washing through my whole body. It was insane.
Yeah, I mean, the thing is,
Incredible.
when you can see them by, you sometimes, if it's that intense, if you look outside, I mean, we possibly can't. I mean, sometimes you can, but you can't see the curtains. You can just see there's an orange glow or a green glow in the sky. That's when you grab your camera, put it on night mode, prop it up against something, and hit that button, because you know there's somewhere in there. And
Yeah.
of course, we've always said this: the sensors on the cameras, on the phones, are so fantastic. And this is why, because people keep saying, "Is the sun getting more active? Are we being attacked more by the sun's space weather?" No, we're not. It's just that our ability to detect them now is far better, because we've got the sensors. The event I was trying to think of was the Carrington event. And of course, in those days, cameras, phone cameras or digital cameras, didn't exist. So it was all done by eye. And the further south you saw them by eye, you knew that was a big event. And then you probably find, if we had had cameras, that event maybe would have even been seen at the equator. You don't know.
Yeah.
But yes, I mean, so it's always worth having a look. And again, with the citizen science, the more people who look at it, the more knowledge we get, the better our chances of being able to predict when these things are happening. But the universe has got its own mind. It's going to do what it wants. It's not going to tick to our time. So yeah. So how are we doing, Rog? Hello, Roger. We haven't lost him again, have we? Oh, he might be uploading. Like this happened last time when he was uploading his things. So yeah, I mean, get yourselves onto the WhatsApp, the citizen science things. Again, a little bit later on, when give me a chance to have a bit of a break, and we want to see Roger's week in the sky and the gallery, and then we'll go back to, and I will show you how we use Zooniverse live, hopefully, if everything works. But it is so simple, so simple. People are always put off that they're going to be asked questions about science, about maths, and things like that. It's nothing like that. It's most of it's observational, and you're given a full tuition. And there's also what they call a field guide that you can click on. If you're unsure, you can go on the field guide, and it will tell you. It'll give you pictures of what you're looking at, so you're getting the right one. I mean, I was actually surprised, because when I went back on it to do the research on this, I didn't realize it was done 2022 was the last time I'd been on there. But the hours, when you looked at the hours, they were massive. So of course that was when we had COVID and that, so in the lockdown. So yeah, I was able to get away with it then, but not so well. I can now because I'm retarded. But yeah, it's just really is You get so involved, you get so pulled in. So how are we doing, Rog? No, he's still sharing. Still sharing.
Can he not hear us when he shares?
I don't think. Well, I think it's because he's uploading to the stream. His machine's not coping, so he loses a bit of power. So, but we had a little bit. We had this earlier on when we first came. Well, when we were in the green room setting everything up. So Kenneth Holmill has just said. Let me get the chat up. Let's have a look at the chat. Oh, welcome to everybody as well. I did forget. I was a bit thing. So anyway, there we go. So Kenneth says he's just got himself a new Aurora cannon. Okay. What do we mean by cannon? Are we talking a telescope or are we actually talking a Canon camera? So anyway, yeah. So here's what does Ian say?
Oh no.
Here we go. Ian says Aurora is unlikely to be visible by eye or camera from anywhere in the UK. Aurora Watch UK. So I'll take it you've just been on there. Well, the event probably hasn't hit us yet. So it's only when it starts to hit. Of course, I mean, it all depends how sensitive you've got your app set to. If you get an alert on yellow, then there's a good chance you aren't going to see anything. But if you've got it to amber, that means you're just one step away from a decent geomagnetic storm. So hopefully we need sort of for us we need sort of like a geomagnetic storm in the high twos or the threes even for us to be able to see them at the latitudes we're at. So yeah, it all depends which system you're using. Melinda, could you put Roger back on? Oh, he's already on, but we don't know whether he can hear us.
Hello.
Hello.
Oh, you here? Is everything loaded now?
Can you hear me?
Yeah, we can hear you. Can you hear us?
Yes.
Yeah. Is everything loaded?
Maybe.
Let me have a look. Let's have a
I
look.
don't think Roger needs words because his face is so expressive. It tells you without words exactly what's going on.
I don't know whether you heard earlier, Rog, if you can hear us now. We were
I've heard
talking about
everything.
how what about your hair?
Yeah.
About the lunar highlights. If anybody wants hair
Look
hair
how
like that.
perfectly it matches, though. It's beautiful.
Yeah, it is. With
Well,
the
I wouldn't
comb
go
over.
that far. Yeah, Bobby Charlton.
Yeah, 4 strands. Okay,
Right, are we going to do my What's in the Night Sky then, or what?
Yes, we're going to do it. So here we go then.
Yay! Okay, so the first full week of July 2025. Woohoo! Right, so we've got Mercury's eastern elongation in a couple of days, so that will be shining nicely. So keep an eye out for that, although it will be still very low on the horizon. So be very careful when you're trying to look for it without getting burnt eyeballs. So there might be a chance of some Perseids, although that's not quite ready yet, but there might be start of some activity coming up later in the month. And then we've got some planets in the morning, but all that to come later on in the presentation. So we're currently going up through the phases towards a full moon later next month, but it's not been looking too badly at the moment for those lunar lovers like me. So it will be visible roughly 30 to 45 minutes until sunset, after sunset, and it will be a magnitude 0.4. So there is a chance, if you've never seen it, just have a look for it. It's like a little tiny star. So if you want to have a look for Mercury for the first time, just be careful to look for it away from the sun. You have been warned. So just some information here about where to look for it, and obviously binoculars, but be very careful. Right, so we've got Venus, Jupiter, and Saturn, which will hopefully be visible at some point before sunrise. These images are from myself and others, so gives you an idea. We do have Venus shining at minus magnitude 4, so that's quite easy. Jupiter's not so bad at minus 1.7 magnitude. And not far behind that is Saturn, although Saturn will be the first of these 3 planets to come up before the others and before the sun. So if you're up or still up, and have a look for those, it will be quite nice to see. So good seeing for that. So on with the show, and what's in the night sky for about through the week. During midnight, as you can see, we do have the summer triangle nicely up in the southeastern skies, with the core of the Milky Way now becoming visible through Scorpius and Sagittarius. So good opportunities for getting some Milky Way shots through the to the gallery, please. That would be good. And yeah, we've only got the moon to keep our companies with all the planets. Now Mars is pretty much set, and then we've got all the other planets coming up just before sunrise. So fairly planetless during the night sky, really. But during the morning, we've got Saturn well ahead, followed by Venus, and then Jupiter getting quite close to the sun. But they will be visible just before the sunrise. Okay, so we do have a possibility. Sorry about this. It seems that Gamma seems to think that Perseids look more like comets, but
We
can't
wish.
have everything.
We wish.
Yeah, so there might be a start of a very small amount, as it says, maybe 1 to 2 per hour under the first conditions during the July, but obviously it will peak around mid-August. So looking towards the end of this month, really, to have a look for those. They seem to be the most popular, especially it's during the summer, so we got a nice chance to be outside enjoying that warm summer air, unless winter comes early after all this hot weather.
Yes,
So yeah, so we've got obviously the summer triangle. So we've got Cygnus, Lyra, and Aquila, obviously with Deneb, Vega, and Altair making up those 3 bright stars. And then down in the below, we've got where the heart of the Milky Way core is, down through Scorpius and Sagittarius. So hopefully we shall get some interesting. So we obviously need to try, and if you can, just use your digital camera or even your phone to be able to get those images for you to send into the gallery. So we've already got through that. So we have, right, now the more important thing is the gallery. So this week we've got one from Jerry, which was the Pelican Nebula. This is a reprocessed image. So one that he's taken before, but he's had another go at. And he's produced this magnificent specimen.
Oh, that's gorgeous.
Very nice.
Very nice.
Lots of nice details going through that cloud details there. Yes. Well done. Okay, so we've got a few from Lou this week.
Yay.
And this is one of his. I guess it's done with his Sea Star, and this was done while he was doing a trip to Bryce Canyon in Utah, where he's got Bortle 2 to 3 skies. So,
I love the Trifid Nebula.
Lovely.
Yeah.
Gorgeous, yeah.
Yeah. Done nicely there. Well done, Lou. And this was earlier this last few days of the sun in HA. Now it's the same image, but one's done as a positive and one's done as an inverse. I don't know which one. I mean, the inverse image always seems to show the surface details in a better light than the ordinary one, but it's just personal taste. You just got to get used to. Yeah, I mean that's the main reason why I did it. The only thing is, do you like black sunspots or white sunspots?
Well, I think black because it's traditional, but like you say, it certainly does give you a different perspective, doesn't it?
It certainly does.
Both lovely.
Let's put it this way, they both got their value.
Yeah.
Yes.
Mhm.
And here's a picture of the moon that I took last night.
Ooh.
Aw,
Nice.
Ooh.
very nice.
Crispy.
Yes.
Very crispy.
Yes. And this was sort of early evening, so it's quite a bright, still bright daylight out there. So that's why it's got the bluey coloured sky. I thought it got some quite nice details there. Me being a selenophile and all that sort of stuff.
You can get ointment for that.
Yeah, I know. Right, now back to Lou. Now this is the IC 1318, which is near the Pelican Nebula, and this is the Sadir region. It's a little bit noisy, but he's getting there with his processing.
Yeah.
You just have to persevere with it. So
I also think that looks a bit like a cropped.
Yeah, I think
image,
it's been
but
cropped as well,
so,
but there we go.
But yeah, a bit more processing, and you could be able to bring out some lovely detail in that.
Yeah.
Yeah. And then he's taken a picture of the crescent moon while he was in Bryce Canyon, and there were some forest fires nearby, so he's got a smoky sky there.
Moody.
Very sultry, isn't it?
Very
That's a
moody,
silky sky with a moon in it. That's lovely.
Yep.
Almost poetic.
Yes. Okie dokie. And then we've got the Eagle Nebula with Lou's sea star, and here we go.
Well, that's nice.
Yeah. You can see the pillars of creation there, right in the center of the picture.
Yeah.
Yeah.
So he's done well there. Well done,
Very
Lou. Yes. Okay. And this is only just done today, so I thought, there's something going on around the surface of the sun.
Oof.
So I quickly, sort of almost on the opposite sides of the surface here, so I quickly grabbed this and posted it for tonight. So there's some quite.
I was just going to say, so one's coming onto the face, and the other is leaving the face. Lovely.
That's correct. Yeah.
The one on the left looks like, a really zoomed in macro shot of a spider, the top of the eye.
Oh, a dead spider, legs up in the air, or a molted skin of a spider.
Yeah, it looks like one of those little jumping spiders, doesn't it, when you get close up?
Yeah, when you get really close up, just those little eyes peeping over the top.
No.
Hello, I'm coming. Sun spiders.
Sun spider.
If we start getting sun spiders, I will be leaving Earth.
Very apt, actually, given the new movie that's about to come out with the Project Hail Mary with Ryan Gosling.
Oh yes, that's looking quite fun.
Eaten.
So this was done just before I came on tonight, and this is tonight's moon. I thought, oh sugar, I'm not going to be able to get it once the show's over, so I better do it now. And this is the result.
It'll be a bit dark.
Lovely.
Still crispy.
Crispy,
nice
very
and
crispy.
Crispy. Okay, enough of that. And as previously mentioned, some not lucent clouds which were last night. Now these were done on my iPhone, so there we go.
Stunning.
So jealous.
Yeah.
I didn't see any last year. I don't think I've seen any for 2 years, and I keep longing and no.
They're so pretty when you see them, Rachel.
Yeah,
they really are.
I think the last time I saw some decent ones was when Comet Neowise was up in the sky.
Yeah,
5 years ago. And that was the first time I ever saw them. So
yeah, same. Yeah. And I was so excited. I remember still like the feeling. Same for seeing Neowise. It's one of the best things. Yeah. But you want to duplicate that feeling again, and
yeah.
At the minute, it's not happening.
Yeah. So these were just camera, the phone on a tripod, and 5 seconds exposures, and there we are.
And
In
what
fact, you
time was
can't-
this, Raj?
Just about 11 o'clock at night.
Oh, this will be why I'll be long asleep.
Yeah, you've been asleep for about 3 hours
I'll have
already.
watched 3 episodes of Downton Abbey and I'd have been asleep by then.
There are some
Yeah,
stars in the sky here as well, so they obviously pick that up as well, just about. So I think actually that yeah, I'm not quite sure what the constellations are, but there we are. So that's what we've got for this week's gallery.
Lovely.
Thank you very much.
Oh, thanks for that, Rog. That was
Thank you, Raj. Yeah.
absolutely stunning. So thanks
Yes.
for that. It was well
Yeah.
worth the wait.
Jerry and
Well
Lou and
worth
the
the
gang.
wait. Yeah, well done, everybody. We always enjoy seeing your images. So don't forget to send them in. If you what's the
Right, it's gallery at SpaceOddities.space.
not space, yeah.
Yeah.
I thought
One image
One image at a
per
time.
email.
Yeah.
Yes, unlike Tom Cruise there, who also names them wrong as well.
Once, only once, only once.
Oh, you'll never be allowed to live
You
that
couldn't
down.
tell the difference between the Crescent Nebula and the Crab Nebula.
Oh.
I
You know, it's
don't
more
know.
embarrassing when I've had like some of mine chosen for publishing and stuff. I just forget and send the images. Like they ask for pictures, I will send them, but I forget that I call them ridiculous stuff because it's me. So like when when we sent in things like the Horse Nebula, it actually went in, and then I realized after I'd sent it that it was labeled Horsey Horsey Nay Nay. And I was like, I've just sent this to like several people, and it's down as Horsey Horsey Nay Nay. And I think I've had others where somebody replied. I think it was somebody at the SPA magazine, like, why does it say Taddy? What's Taddy crop? I was like, oh, it's the tadpoles, but I cropped it, so it's called Taddy crop. And I just think I've got to start renaming them before I send them to people.
Yeah, check before you hit that send button.
Yeah.
Horsey Horsey Nay Nay.
Yeah. So anyway, thank you again, everybody. Those images were lovely. And as we said, there's plenty of keep your eye out for those noctilucents. And of course, if you do capture any of those Perseids, then please let us know and let's have a look at them. And it's funny because sometimes you won't be concentrating on the Perseids and all that, but you'll be doing something else and they pop up. But when you chase them, you can't find any of them. They're all they're all in different parts of the sky.
Murphy's Law.
So
Murphy's Law.
they all happen behind you. Yeah, and then you turn your camera around and they start happening the other side. Anyway, that's by the by. Right, okay then. Thanks for that, Roger, and everybody for that. So we've still got a couple of little bits to go for. So shall I do my Zooniverse bit next?
If you want. And
Or
then
do you
I've got
wanna
my
do-
constellation of the week.
Yeah, okay then, that's great. So we'll do because I've done me something now. So right, okay then. Right, I'll get this up. Doo-doo. Doo. Right, I hope everyone can see this. Now I've got to. Can you see my cursor, or have I got to go onto the
Yes.
site?
We can see
Oh,
your
you can, yeah.
cursor. Yes.
Well, let's see if it actually does anything. Let's
Ooh,
if it,
that'd be good.
oh, that's good. That means I'm going to go onto the other side. Right, as I said, this is the Zooniverse app. When you first log in, as I said, you can either do this for free or you can sign yourself up. And as I said, if you sign yourself up, you will be accredited with with your name put into the actual scientific papers that are drawn up from them. So you actually become a named scientist as such, but an amateur scientist. So this is the first page that you come to. As you can see, that's all. You got favorites, collections, comments, and messages. That they're all self-explanatory. But what we will do is we will though, if I scroll down, you can see what's actually on here. You scroll down. Now it says these are my groups, the ones that I'm actually doing. I think I've got about 5 going at the moment. You can join groups so you can actually see the chats and things like that. So we'll have a look at these a bit more. Now, this is some of the things that I've been doing quite recently. This is looking for or classifying gravitational waves. So this is Gravity Spy. Let me just bring that down a bit so we can see the two. So this is Gravity Spy. And basically, I will click on it so we can have a quick look. This is where I'll end up losing myself somewhere. Now, as you can see, let me just get rid of this one at the top here. See, it says that, as I said, it's the Virgo and Kagra network, and it has extended its 4th observing run. So this is what we're working on now. So we'll just get rid of that. So you actually get live information as it comes along. Now, as you can see, I've got several levels here that I've actually opened. And there's also several that are locked here. This is a picture of one of the actual observatories itself. So let's just start with the basic one. So what we do is we click on here. No, I don't want to go to the new flow yet. Now, this is what I'm looking at. Now, this is the basic. I hope you can see what all this is all falling into place, is it? Yeah.
Yeah.
Yeah. So, right. Okay. And then, so what we're looking at here is this is from Hanford. This is a time scale. That's the frequency. La, la, la. Now, this is the basic one, which you actually start on. And what you're looking for is blips, whistles, and none of the above. So basically, you look at this. What does it actually look like? Well, it actually looks like a blip. Now, if you're unsure, you can either go to the tutorial. Hope you can see that. And that will tell you, you can go through that and it will tell you everything that you need to know. You can click through. And it basically, this explains what you're looking for and how you're actually going to do it. So, you know, everything's there for you to be able to do this. And so on. So that's your tutorial. So we go back to task. If you don't know, when you get a bit further on, a bit more advanced, you're given more things to look for. So in this case, then, if I find something that I'm not sure about, I can go to the field guide. And this will give me all of the different things. And this is what you'll be looking for when you get to the full thing. There are loads of different things. So you're starting with the real basic stuff at the moment. So let's go to task again. So basically, we're just going to say this is a blip. We'll identify it. Done. And I'm on to the next one. Again, this looks again like a blip, so you would do exactly through the same thing. But if you're not unsure, then all you do, you don't guess, because it skewers the research. Is you just refresh the page, and you'll come up with the next one. So this is basically that is the basic, and this is gravitational waves. And I think on this one I've identified of something like 17 on here. So yeah, so we'll just we've got to go back. So here we are. Then we're back to the start, and then we'll just come back out of that. So then we've got here the WASP variables. Now these are these here, and what you're looking at is the dips in light as the planet moves in front of the target object, and this will tell you exactly what and the profile will tell you what sort of image, what sort of object is actually moving in front of the actual target object. So here we are. We'll just click on it and just give you a quick look. So again, you've got you can find your it tells you, of course, as you scroll down. So I didn't do this on the one. You will get more information about what is actually the project and what you're actually looking for. So, and there's extra links that you can click on the right hand here. See, it says there's 17,219 volunteers, classifications, 4,883,776. So this shows you how advanced it is. You got different subjects, 2 million odd subjects, and complete subjects, and so on. So to join in, all you do is just click on join in. Where have we gone? I've probably gone the wrong place. Oh no, I've joined the. I know what I've done. Sorry. So let's go back. So right. So get started classifying light curves. So here we are. Oh, there's a wibbly wobbly one. Now, what you're looking for is you can see that there is something moving in front, but you're looking for this being the same all the way across. So you've got to look for where the drops are and whether or not they're repeated. And that's and then you've got all these again, this is where you need the tutorial, and you also need the field guide, which is over here this time. You're looking for pulsators, EA and EB types, EW types, rotators, unknown, and junk. And basically you base your choice on what you're actually looking at. Because this is the data, this is all the data points. So you can see here all this white, and the actual red line is following the actual curve of the line. Now this one seems a little bit erratic, but there does seem to be a pattern right in there. And what you would do is possibly pop on the field guide and then possibly have a look and see what you think it actually is. And I'd have to have a bit of a further look at this one before I actually make a choice. So anyway, and then I'm not sure with this one as you actually go on whether or not you will actually enter into new levels. So that's that one. And as I said, these are so addictive. This is the one I was on about earlier on about sunspots. What we're learning here is you can either get started or learn more. It'll give you a full history of what's going on. And we're looking at these old drawings, the drawings that you see like with the Carrington event. And what we're actually doing is we're counting the sunspots. But you've got to be careful with this because that's possibly a sunspot, but there may be another little spot on here which isn't actually a sunspot. So let's get started. Have a look to show you. And this one, and this is what one of the problems actually is that sometimes they are really small. And what you're doing is you're counting the big sunspots, but also in here could be small sunspots or around the edge. So this, I'm basically just going to say there's one sunspot there. Bump. Done. Next. And that's giving me that. And as you can see, I've got a lot more to count here. So basically all you do is you count all the sunspots. There's a little dot there, which is probably just a bit of a smudge or where they've dropped their pen or something. But this is what you do. And you're counting all these sunspots, and then you put the number into here, and that's done. And you've started your science. You've actually started adding to the scientific discoveries and also the history of sunspot observation. So also I've got here on Stonehenge, and what it is radio meteor zoo. And what this is we're looking. Let me click on it. Get started. Right, now we're looking at radio blips that have been created by meteors passing through the atmosphere. Now you can see here, I mean this one, what you have to do is there's a rectangle tool. I'm not going to start this one because I won't finish it in time. But what you're looking at is you got one here, one here. There's another one just in there, there, and you put a rectangle around all of these, and it will actually count them for you. So over this period, you add all these things, even these sort of like faint ones, and then you've got a nice thick one here. But you have to go on there, and it will actually count them for you. So as you click on them, and sometimes you can put up to, I think the most I'll put up was 35 on one of these pictures, and this one's not going to be far off by the looks of it. You're not really looking at the smudges. These lines are something completely different. You ignore them. It's these little blobs here. I mean, here you've got a group of 4. got 2 very small ones and 2 medium ones. So that's all you've got to do. You've just got to put a rectangle around them. So what you do, and what they're after is you've got to catch the main part of it. So if I do this one here, I hope you can see my cursor. That's it. And you'll see it's drawn. If you go over here and look at the rectangle tool, it said I've drawn one. So that's basically how you go on. I'll remove this because I'm not going to carry on, because if I say done on this, it will say it will be false data, because on here there's probably about 30 odd on there. If I send in a 0 or just a 1, it'll skew the data. So we'll get rid of that and then we'll come back off. And what's me last one? What was the last one? And then we have now I've got here cosmic collisions. Now this one is actually classifying galaxies through the Webb telescope, and what they're looking for is basically you're looking at what your main object is. You'll get 3 images, and what you're looking at is the main object in the middle. You've got to try and describe what that is, what sort of galaxy it is, and whether or not it's interacting with its neighbor, if there's a neighbor available. Now, looking at this one here, you can't see if there's a connection here, but there does seem to be some sort of connection here. So, of course, you'll get bigger images of this. So let's get started and have a look at one. Here we are. Now we've got a galaxy here. It looks a bit on the irregular. Let's have a look. I can't see a disk in there. Can't see a disk there. But I can see these blobs. Now these are so first of all, I've got to decide whether or not it's a disk, a spheroid, or a regular. Now personally, I would say it's an irregular. So we'll go next. If the sample fits multiple categories, pick the secondary. It may be a spheroid, but I'm not saying it's not applicable actually, because we have all this on the outside here. Do we think it's a spiral? Blum 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 blum. But what we can see is these clumps here. So is that actual star forming? And the reason I say is it's star forming because of this, what looks like a bridge here with an object over here. So I've got clumps. There is a bulge in the center, or there is what we're seeing, a bright center. And again, what we will do now is we will move on. We can't see a bar, we can't see a ring. So we'll move on. Now, is there a merger? Now you've got to make a decision here. Now this is a blown up version of here, and these are the clumps here. So we know something's going on. I don't think those are the cores of merging stars, but there is something up here in the left, on the right, sorry, on the top right corner, and there seems to be this star bridge between them. And if you look, the star formation, the clumps here, are in that drift. So there is an interaction appears to be going on here. So I will say we got an interacting companion. So I'll put that in, do that. So that's my classification. It tells me what my answers are. You can change them if you wish at this stage. Then you go next, and then you come on to the next one. Now this one's even more. I mean, it's just a little clump. But that's basically what I'm doing on the universe. But let me come. Oh no, don't want to go there. So go back here. So right, let's see if we can find. Again, like I said, if you come down, there's lots of things that you can interact with. Transcription, tool evaluation, project results. You get updates on the results. NASA live event, Euclid images. There's lots of things that you can actually be reading and having a look in here. Now, what I'm looking for is categories. I can't find. Will I find the movie? Let me just go back one more. Oh, I can't. No, will not do it. So, see, I've actually done 444 classifications. That's how many objects I've found myself in these 5 different projects. And you can go and you can get stats. You can also print off yourself sort of like a uh, uh, little certificates, a participation certificate. So that's how it actually works. But when you come on the first page, which I can't seem to get back to at the moment, I might have to. Come on, you gonna let me in? That's not going to let me out. So yeah. So basically, that's what we're looking at, and that's how easy it is. Everything you need to know to actually start a project is there, and I guarantee you, within 10-15 minutes, you are doing the classifying. So that is how easy it is to use. As it says, there's over 200 plus different classification projects ongoing, and they cover so many. Like I said, there's things like deciphering old papyrus, diaries, things like that, all historical events. There's earth science, lots and lots of earth science. And then, of course, there's the astronomical. You can even, I think there's even a planet, I said before, there's a planet hunter on here. So I hope that helps you in how easy these things are. And I do believe maybe Roger's got
It's like a
one.
astro nerd version of like Where's Wally? It's great. It's,
It
I'm
is
sold.
exactly. It is spot the diff, and also there's like I said, there's one in the NASA site called Moon Diff, and it's literally spot the difference. You're looking for those things that have changed since the last image was taken. So it's fascinating. But like I said, be warned, you will lose hours. You just sit there. Oh, I'll do just one more. Oh, just one
All right,
more.
I
Oh, I
can
know
handle
this
that.
one.
I can handle that.
And yeah, and it is. It's just you just click, 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 and occasionally what they do is they'll just to keep you interested. As I said, with the gravitational wave one, I've opened about five or six levels, and of course that means as you go up, you're trying to identify more and more. But with the field guide, it's so easy to say, "Oh, I'm not sure about that. Let's have a look, see what we can see in the field guide." And if you click on those pictures, it will tell you what you're looking for and things like that. And some of them are just lines straight across at a certain wavelength. But yeah, it's nice when you get, and then they'll give you a report. Yes, you've discovered or you've confirmed a sighting. So, but of course, like I said, you're not the only one doing this. Don't worry if you make a mistake, because hundreds, if not thousands, of people are seeing the same images and they're also analyzing. And of course, what they'll do is they'll look at them all and say, well, the majority have said this. This is probably what we'll go with. So that's citizen science. Roger, did you have one that you wanted to show?
I have, but let me do the constellation of the week first.
Oh, okay then. Yeah, right. So you want
Because
to
my
do
citizen science one is related to an upcoming event that we're doing in on Mars month in September.
Oh, in September. Oh, actually, fantastic. So
I thought that seemed quite appropriate. This one that I'm going to be doing, which I'll show you after this.
Okay, then here's constellation
Right,
of the month,
and it's Auriga.
Ooh.
So there we go. This is more of a winter constellation, but I thought it's got some interesting things, so we'll do it for the moment, so we can get people more excited when that does actually happen. So we've got Auriga, which was Latin for charioteer, and its brightest star is Capella. So it's particularly interesting during January when it gets the highest point of the sky. So we're at the opposite end of the seasons for it at the moment, but fear not, that will come around soon enough. So Capella, the little goat in Latin. So it's sixth brightest star in the night sky, and it's 42.9 light years away. So it consists of 2 pairs of stars, 2 bright yellow giant stars and 2 red dwarf stars. So,
very interesting.
How many people knew that before just now?
Didn't know that at all.
Yeah, well, that's what I've been told anyway. So, we've got through the different types of stars that we have through the constellation of Auriga. And if you look over on the right-hand side, the column there, saying there's a lot of variable stars and some double stars there as well. So on the whole, there's a lot of variable constellation, which is quite interesting for those that want to do that. I'm sure there's a citizen science project for variable stars. Watch this space. So just concentrate even just on one constellation would be quite a good project even on its own. So it's a kite-shaped object between Taurus, Gemini and Perseus. And obviously being at its location is obviously most likely to be best seen during the winter months. So we have got Auriga, most commonly identified with, here we go, Eryxithonius of Athens, son of the god Hephaestus. So I'm gonna stop pronouncing these things because it's all.
Do you need a tissue now, Rod?
As they say, it's all Greek to me. Ha ha
ha. And he was born with serpent lower limbs. Oh, okay.
Yeah, okay. So there we go. Anyway, that was quite a good thing. So we've also got other different mythological stories. Myrtilus. Some myths connect Auriga with Myrtilus, son of Hermes and charioteer to the god Anemus. So after betraying his master and causing his death in a chariot race, Myrtilus was killed by Pelops and placed among the stars by his father Hermes. And then we've got Phaethon. Sounds like I got a list. Another association links Auriga to Phaethon, the son of Helios, the sun god. When Phaethon attempted to drive his father's solar chariot across the sky, he lost control, scorching the earth. Zeus struck him down with a thunderbolt, and his image was immortalized in the stars. So there seems to be a bit of a theme going on here. And then we've got the goat and kids. 3 minor stars in Auriga represent the kid. This connects to the story of Amalthea, the goat who nursed infant Zeus. The constellation's brightest star, Capella, represents the mother's goat carrying her kids safely on her back.
Aww.
So, yeah, some sort of happy stories and some horrendous stories. But there we go. So there we go. So even back into the past here, we've got Mesopotamian vision here of the constellation of Auriga, and it was known as Gam in the Babylonian star catalogues.
Well, that was easier to pronounce.
Yes. And then the Bedouins viewed these stars differently, associating with a herd of goats, as they do. Pastoral interpretation reflects their nomadic lifestyle and the importance of livestock. And then the Chinese incorporated it into their celestial emperor's chariot configuration, emphasizing the universal importance of chariots as symbols of power and mobility. But even back in those days, see how the star are sort of connected with the lines here on this tablet. So goes back years and years and years. So we've got some
sorry.
Yeah. We've got.
I was just going to say how tactile that tile was as well, because they're raised above the surface. So very
handy for those with vision impairments as well.
Exactly. Yeah. So it was very advanced, really, wasn't it?
Yeah. All we need is a new version with some braille for those to really understand it all. Very good. Right, so we've got 3 Messier objects, 36, 37, and 38. They're all open clusters. So those that want to put them on the marathon, don't forget to quickly go through these, as they're all fairly close together in the location there. So 136 is 4,100 light years away. 37 is 4,500 light years away. And then we've got 4,200 light years away from 38. So they're all of a fair distance away, but worth having a look if you like open clusters. Right. Okay. So all we need to do. What I'm confused about with this picture was, why is the astronomer stuck in waist deep snow with his telescope? Was that a sudden deluge and he got caught out there? I don't know. Anyway, there we go. So it's just basically trying to have a look during the winter between 9 and 11 o'clock when it gets to its highest point in the December skies through February, to get an opportunity to have a look at this constellation, really. Okay, so obviously we've got all these different types of versions of the constellation, so it's quite interesting to see how different cultures have interpreted the constellations and how they want to view them as a story in their histories. And there we go. So there we go for that.
Very good.
Right. So if we want to go on to my citizen science now, this one is quite an interesting challenge, as I say. Daz, hello.
Hello.
Right, can I do my? Oh, you were doing some citizen science, were you?
Yeah. I'm hooked. I'm hooked, man. Let me just find it again. So that was your constellation.
Yes.
Okay, then, mate. There you go.
Right. Okay. So we can now go on to do my citizen science project, which ties in with our September theme of Mars Month. So this one's cloud spotting on Mars. So we've got the Mars Climate Sounder, which is currently in orbit, going around photographing the surface of the planet, and we're using its information to get more information about the cloud structure, how it forms, what type of clouds they are, and where they start and stop. So it's been going globally around the thing for over 15 years. So it's providing lots of information each day and month, providing us keen people to go and check out all these different types of cloud structures. So what it's doing is sending back these information as it goes over the horizon above it and studying it. And as you can see, it's produced an interesting graph here. So the peak of the arch is the actual location of the cloud. So it's like an arch that we need to keep a lookout for. So as Daz says, you'll be represented with images with that span 4 hours worth of the observations. So it goes from left to right. So as it comes over the horizon, it starts to pick it up, and then as it passes its peak, you get this like wishbone structure here. And this is what we're trying to look for. So what you basically do, you mark the peak, and then you see where the either side of the peak goes down to. So you need to look at the 2 legs with a clear gap between the top of the peak there. So what we need to do. So why are we studying this? So clouds are familiar on the atmospheres of planets because they can be both warm and cool the atmosphere. They are important for the understanding the weather and the climate. On Mars, icy clouds can form through the atmosphere and may tell us about the winds, which are otherwise invisible to spacecraft and researchers. Although Mars is a dry planet, there is water vapor in the atmosphere and can form water ice clouds. However, because the atmosphere is made up of almost entirely 95% of carbon dioxide and it's cold, carbon dioxide ice, like dry ice, forms. So that's what these are basically do. So the important question is, with your help, we are investigating about these clouds. So what are they? What are the daily, seasonal, and annual patterns of Martian cloud shapes and distributions? How well do clouds form reflecting prevailing wind patterns? Do structural similarities between Earth and Mars's cloud types point to similar formation mechanisms? And the goal with this project is to first find and map the clouds to create a database that will help answer such questions. So, why we need your help? To do this, we'll be researching through the years of data acquired by the imaging ultraviolet spectrograph. So the IUVBS observes the entire disk of Mars in the ultraviolet to measure water ice and dust in the Martian atmosphere. While most of the images of Mars include some form of dust or haze, large clouds are observed quite regularly in a variety of shapes. There are a variety of recurring unique cloud types that exist on Mars that are also seen on Earth, which leads us to the question of how similar these groups of clouds might be. So we're starting to get the sort of the cumulus and stratocumulus and all the rest of those types of things. So these cloud shapes will tell us that there is water ice present, but also may shed light on the underlying atmospheric conditions. For example, Earth's prevailing winds that encounter a mountain can form a series of waves behind them, with clouds forming in the rarefied air. So as you can see here, they start to get a bit wavy on this image here, which is also visible. And then once we get up higher, they become rapidly cool and condense, forming cap clouds over the top. So we've got 3 volcanoes forming on the surface there, and then as you can see, they've got clouds all the way around them. So provides a similar experience as you might see over on some of the high mountains on Earth. Like you see around Everest or Mount Fuji, you get sort of like these caps going across. Quite interesting. So over the short-term goal is, beginning with our higher spatial resolution data, we hope to identify and map 6 major cloud types in order to create a useful database for scientists in reference in modeling and data analysis. Along the way, we may discover other unique clouds, and these too will become useful in subsequent studies. As the investigation progresses, we will include some of the lower spatial resolution data from the IUVS and see whether clouds can be spotted in those as well. But on the long-term goals, we hope you will join us in finding clouds over the life of the MAVEN project mission 2014 to present. With your help, we can determine how these cloud types appear and change during different seasons on Mars, and to use this information to enhance our understanding of the dynamics of the atmosphere. These results will create a new library for all Mars scientists, including you, that reports on the frequency, spatial extent, and variation of these forms throughout the years. With this substantial library, we can begin to investigate how year-to-year variability presents itself and the mechanisms inhibit or encourage cloud formation in the lower atmosphere. However, we will likely be more help from citizen science ourselves to understand these changes. So obviously this is going to be helping any future Martian colonists be able to get a decent weather forecast of any forthcoming events that might be coming across over to where they are located. So it could be quite interesting, and I'm interested in seeing how this project will go. So maybe by September I'll have a more understanding concept of how these clouds formate and where they come from and how they grow, change shape and disperse, and what types of clouds they are and what altitudes they form at during the different seasons. So watch this space, as they say. And we've got the team members here. We've got assistant professor, and it's all been funded through NASA's Citizen Science Seed funding program at the Jet Propulsion Laboratory in California, at the Caltech as well. So it's all done through quite high accolades and academia there to get all this done. So it'd be nice to help these people out.
Yeah, very good, very good. Thank you for that, Rog. That's lovely.
Yeah.
Got a few questions by the looks of it, or some remarks. Let's just bring them up. Let's bring it down. So Ian's asking, would the clouds above the volcano still be CO2 or CO or H2O or what? Well, I'm presuming they would still be.
They would still be the same, just they just form differently around the surface, I expect.
Yeah, it's like you say, we get the same effect on Earth, where the mountains and all that, they seem to attract attract clouds. So what else we got? Sandra says she'd like to do that one.
Oh,
so
right.
She's a Mars
Why not?
person.
More the merrier.
Yeah, we know Sandra because she likes Mars because it sounds like a bar of chocolate. So we've had that conversation before. There was Kenneth. He did have a remark, very cynical. Let me see if I can find it. Okay then. Cheers for that, Rachel. John has appeared in his jammies. So where was Kenneth? It's disappeared. I can't find it. Basically, he was saying that this is how scientists get ordinary people to do their work while they sit around the office chatting. So
how
yeah,
rude.
very cynical. But are there strawberries too? I'm lost on that one.
I think that's referring to Johnny's pajamas.
Oh, that's me trying to be serious, and we're all talking about Johnny's pajamas.
You sound like Terry Wogan, Dan.
Also, Ian's asking, is this still Zooniverse, Roger?
Well, I presume so. Well, it's all part of the citizen science on the website there. So
yeah, because
it's all listed there. So carry on.
It's a dormant. Sorry, I was just reading Lou's message. Lou's message just says yes, the volcanoes are dormant. Yeah, well, of course, yeah, but we all know that the volcanoes are, well, there is no sort of volcanic activity or tectonic plate activity on Mars because it's totally cooled down now. Well, to a certain degree. So yeah, I think that's it. I can't see any more. Now the reason I got held up earlier on is that I unfortunately here we are. This is the cynic. This is how astronomers get others to do their work so they can chat around in the office all day. Well, fair enough. Yeah, if you can get other people to do it, it's it's a way to go. See, Ian also points out that's what we were saying before, that AI does not pick up everything because the humans, our brains and all that are rigged to recognize patterns. And also, if a pattern is disrupted, then we will notice it, whereas AI has struggled to actually do that. Yes, you can get told off by the Professor AI. Anything else? Not liking crowns at all.
No.
Oh, yeah. Right. Okay, then that seems to be everything. Thank you everybody for staying with us. Sorry for a few little glitches. As I said, the reason I unfortunately missed when Roger finished his other thing, I wasn't actually on Zooniverse, although it was tempting. But unfortunately, and I must apologise again. I absolutely I blocked Ian by mistake. I was trying to block somebody else, and it jumped just as I was about to click it, and I blocked Ian instead. So yeah, sorry about that, Ian. Well, we love you. But yeah, so anyway, I think that's it. Everyone, anyone else got anything they need to add or would like to
No.
say?
No.
Okay then. Well, thank you very much,
Mm.
everyone, for joining us. I see you've
Thank
stuck
you.
with us all through this, even my ramblings. Next week, I'm not sure what we'll be doing next week, but obviously we will find something. Oh, there was just
Mm.
one piece of news I wanted to bring to you, and it's another blow for the SLS, the launch system that's supposed to be taking us back to the moon. They were developing a brand new booster. It's a bigger booster. It's longer, so it'll last longer and it'll give more power. On the test stand, it went pop. It's everything started finally, and the difference is they've extended it to give it more length of how long it'll work. Because these solid rocket boosters, as soon as they're lit, that's it. You're gone. You're not coming back. Because you can't. There was no control on them. Well, with this one, they did have actually some control on nozzle direction, and also there was something about how they could control thrust through the nozzle somehow. But unfortunately, as they went through all the procedures, it went bang. And of course, once they're
Mm.
lit, you can't stop them. So they've got to. The only way they'll stop is they'll burn themselves out. So that's another unfortunate setback for the SLS and us getting to the moon. But yeah, I just thought I'd pop that in there because I've totally forgot about it. I was going to do a presentation on it, but anyway, it's time for bubbles. I know we're holding you up. We're all dying for our Horlicks, and see if we can pop out and see these noctilucent clouds. Yeah, I can see dirty grey ones. So yeah, it's thank you for joining us. We'll see you all next week. Thank you, Tom, Rachel, and Roger for being here. It's
Thanks,
lovely
Dan.
seeing you all again. And we'll see you next week. Keep an eye out, look to the stars, keep your eyes up, and enjoy all the sights and the wonders of the universe. So for now, goodbye, everybody.